Okay. 17 is easy. Is x squared plus y squared equal 9. It's a circle. This is a circle with the center is located in the origin 0,0 and the radius 3. And this is x squared minus y squared equal 9. Okay. Wow. Equation 1, equation 2. It's a my non-linear system. Entonces, en this case es obvio. What is a fantastic way to solve this? Tell me. Substitution or elimination?
Eliminate the two y's.
It's obvious because when you add equation 1 plus equation 2 without do anything, by column, the column of the x is 2x squared, the column of the y disappear, equals 0, no? No, 0, no. 9 plus 9 is 18. There's no subtraction, it's addition, 18. Divided by 2. Quadratic equation, square root is plus or minus 3. To find the y value, well, I use the either equation. I don't know why I select the second, because I like, no specific reason. I copy and plug it in, plus or minus 3. I can plug it in both simultaneously because the square becomes positive, it's the same answer. And this is 9, regardless if it's positive or negative. Es obvio, 9. Es obvio que when you subtracting, so 9 minus 9 is equal to y squared, 0 is equal to y squared. Therefore, y is square root 0 is 0. And 0 have no sign, so only one, y. Therefore, in this case, we have two solutions, plus or minus 3, 0. If we can write, if you want, separately, 3, 0 and minus 3, 0, and two solutions. Super, clear? Don't worry, we have time to check everything in decimals because you get 100 points in this test. Okay? Okay, you need to overcome the result for the first test that was no good. No, some students, yes. But in general, I talk about average of the class. Okay? Because I warning the next test is hard and the class is super hard. Okay, let's switch into decimals. So you have no question? Let me try. Okay, you see now, no 16, 17. Oh, look at that. 17, the equation are a circle. Look, the red one is a circle. Do you see this, no? And the blue part is the hyperbola. And the only intersecting point in between that curve is the green point, is negative 3,0 and positive 3,0. End the story. Any question? Any question?
No, sir.
No. Okay. Wow. What's going on? Okay. Okay. So no more equation. Let's move on to inequality. Inequality now. System of inequality. Linear and non-linear. Okay, let me try. 18 problem. 18 is a system of inequality. The first one is 4x plus 3y greater than or equal to 12. Inequality number 1. And x greater than or equal y. Inequality number 2. Now remember that the answer of this problem is graphically because this represents the one region inside the XY plane, no? O sea, the solution is no 1 point, 2, 3, 4, no. It's a bunch of points that represent one specific region that you need to shape. Okay? So what is the strategy? Well, the strategy is always take one by one inequality and solve for y. Let's do it in the first. I copy again. I move 4x to the right-hand side, minus 4x, divided by 3, everything. This is 12. This is 12. I don't know why I put 13. I am crazy. 12.
That formula doesn't work. Try saying it another way.
Okay. Divided by 3. Therefore, is y is greater than or equal minus 4 over 3 x plus 4. Now, I want to, for 1 second, convert this inequality. This is what's important. Isolate y. Now, for 1 second, I convert to equation because the equation help me.
Yes.
Say again.
I was just wondering why you hadn't done that yet. It was sorry. Never mind.
Okay. The equation help me to split the line, que separate. The line separate the plane into semiplane, no? Something like that. This is my rectangular coordinate system in paper. Let's do it in paper and let's do it in decimals, no? Okay. This is easy. Your identification very well. Okay, this 4 indicate me the y and z. So the point 0,4. Boom, 0,4 because this is b, no? Okay, remember y is equal mx plus b. B is a y and a z in our example 4. And slow, no, slow is m, que es negative 4 over 3. I can interpret always because the ratio between wrong and right. Therefore, right is negative 4 and wrong is positive 3, no? From this point, I go down because it's negative 4 unit down. 1, 2, 3, 4, and 3 to the right. 1, 2, 3. By the way, this is the x and z, que es 3,0. It's a coincidence. Not always happen, but in this case happen. Okay, now I try to do the line que connecting this point. I use my rule. What kind of line are you using? Solid line or dotted line? Please help me.
That's a solid line, sir.
It's a solid line. Explain me why.
Because it's greater than with the equal to on the bottom.
Exactly. Equal sign, solid. No equal sign, dot. That makes sense for you or it's confusing to understand this? Because this is, okay, wait. This is the line that separates two countries. It's a boundary. Then, if you include the boundary, it's because it's equal inside the solution, no? So do not include it, no. Okay, so I did that part. Now I need to shape. I need to shape using maybe blue color, no? I shape, what part I shape? Below or above the line?
Below the line.
Below the line. Why?
Because it's -3. You're going down, the rise is negative. Not up.
No.
No?
No. You are wrong.
Okay.
Specific. The problem was greater than or equal to 12, so we have to go above it.
Exactly. So the clue, give me the conclusion to select above or below is this symbol. Look. Greater than. And greater than means case above. This is one point of view. I want to explain another. And you shape this country, this semiplane. Another way is using testing point. The famous testing point is the origin, 0, 0, because it's easy. And you plug it in into the inequality. And it's 4 times 0 plus 3 times 0 should be greater than or equal to 12. See, this statement is true, it's because the origin belongs to the solution. This is 0. 4 times 0 plus 3 is 0, and 0 is greater than or equal to 12. This statement is true or false? Totally false. Totally false. Therefore, the origin don't belong to the solution. So you take one arbitrary point here, and you plug it in, maybe you get true statement. Super. You understand very well or no?
Yes, sir.
Eso. Entonces, let's move on to the second inequality, no? The second inequality, wow, the second inequality is weird because I create intentionally to confuse you. X is greater than or equal y, but I need to isolate y. Well, already it's isolated, but on the right-hand side, I need the left-hand side. So you can interchange. Here, I put a y here. I prefer always a y in the left-hand side and x in the right. I interchange. What happened with the sign and the inequality? Stay the same or switching?
It's switching.
Switching, very well. Okay, so now I am doing my relative line. Relative or related line. Because it's a family of this inequality. Okay, help me. This is y x, so no b. No b, that means this line passing through the origin. And it's lower one, no? Easy, 1, 1. It's like that, boom, boom. 45 degrees. Are you using my rule? 45 degrees. Eso, 45 degrees. I put a rule here. Then, are you using solid or dotted? Solid?
Solid.
Solid again.
Solid.
Solid again.
It's solid.
You're right. And what part I shade? Below or above? Below or above?
Below.
Below, because it's less than. Okay, entonces I'm using another color, maybe green, below this line. Therefore, what is my final answer? Okay, the intersection between both inequalities. What is the common part? Es obvio que the common part que both inequalities share is this region. Any point inside this region satisfies both inequalities. Any question?
Not at the time, sir.
No? Okay, no, but let's do it in decimal, no? Because I want to make sure, because I want to get 100 points in this test, right? If we have time. How many days we have? We have today, Thursday, no? Thursday, no. Friday, Saturday, Sunday,
5 days.
Monday. Wow, 5 days. 5 days, no? Okay. Okay.
It'll take me that long to get extra credit.
Really. Yeah, I appreciate so much.
Actually, I'm halfway through it already.
Okay. So you want some glue? When the class is over, I can give some glue. Okay, let's go to decimals to verification this answer. See it's good or not. Switching decimals. Okay, so in decimals, when you are doing inequality, I recommend using the same color. Look, let me show you, 18. In the 18, we have two inequalities, that's it. Look, but I put it both in black color or in blue and red. So the part is the intersection. Is the part both regions overlap. and you can see a little bit dark color. It's like a gray, black, white, gray, and it's a black. Or not black, pero it's a bold gray. And it is a switch. Okay. It's coincident perfectly with the answer that we found before. Any question? Any question?
No, sir.
Oh, no. Okay, good, good. Okay. 19. 19 and 20 is similar. It's non-linear in a system of inequality. And you help me now, right, to solve that. Okay, there you go. Whiteboard now. Okay. Let me erase the canvas. Come on, erase. Okay, good. Now, this is non-linear. 19, 19. Okay, the first one is x squared plus y squared less than or equal 100, inequality number 1, and 2x plus 7y less than or equal 40, inequality number 2. I'm using my rectangular coordinate system because I want to do by hand first. Okay. Okay, let's do it one by one. What do you think about the inequality number 1? What represent x squared plus y squared?
Circle.
Exactly, a circle. A circle whose center is located at the point. At what point is the center? The center. The center is. Okay, guys. Let me recall something. Circle, guys. Remember the equation for the circle. In standard form is x minus h squared plus y minus k squared equal r squared. And the center is located at the point h comma k, and the radius is square root r squared. Okay, this guy is r. So you take out square root this. Compare this equation and this equation. Where is it located? The center. In our specific zone. 0,0. Because I can't see h and k here. So h and k are 0. And r is square root 100, I think. So this is the center, but the radius, wow, is too heavy. It's like that. Whoa. So it's completely outside this rectangular coordinate system. Okay. Let's use our imagination. Suppose que 10 here, 10 here, 10 here, and 10 here. And we are doing the circle right now. Okay, by the way, a solid circle is dotted circle. ¿Es dotted or es solid?
Solid.
It's solid. But I didn't dot it because it's too hard for me doing by hand, like a solid, you know? Now, when you shape inside or outside the circle? It's outside. It's inside, no? Inside. It's inside because it's less than. Less than is obvious it's inside. Just in case you want to verification, using the origin, plug in here, 0 squared plus 0 squared is 0, and 0 of course less than 100. In this case, true. The origin belongs to the solution. So you shade that part. Okay, this was easy. The second part is the linear. And the linear, we are doing exactly the same, similar to the other problem, no? 7y less than or equal negative 2x plus 14 divided by 7. Y alone is less than or equal negative 2 over 7, like a fraction, x plus 2. Entonces we discover que we have a line, o sea, the related line, something like that, the y and z is 2, I plot the 2, and from this point 2 down, and 7 in this direction, to the right. Entonces we are ready to do the line. The rule maybe? Ow. Okay. Using the rule, we connecting this and this. In this case, also solid, right? You agree or disagree? Si I make a mistake, you let me know, guys.
It's also solid.
Solid. And what part I shape, below or above?
Below.
So it's greater than.
It's greater than or less than? Pero,
no, y is less than, so it's below.
Below. Entonces, conclusion, the solution is inside the circle and below the line is that part. I include this line. I include this arc of the circle inside the solution. Any question? Super clear? Super clear? Just in case, I want to check in this. Okay, let's go. Let's move now. There you go. Okay, this was the 18. Now 19. Boom. In this case, I'm using green color. Look at I put equation. And that's more fantastic because you don't need to isolate. So you put directly the equation in implicit form. Remember in algebra, the equations you can write in two different ways. Explicit or implicit. Explicit is when the y is isolated, it's more clear. The word explicit indicates us que es more clear. Because when it's implicit, implicit means something is hiding. No clear. But in Desmo, no. In Desmo, everything is clear. And you copy the equation exactly the same you have in the test, you copy. And the first, give me the region inside the circle. Look. The second is below the line. And both together is inside the circle and below the line. Okay? That was 19. Which one? Okay. Okay. In this moment, you see the board, right? Okay. 20 is similar. 20 is very, very similar. 20 is x squared plus y squared less than or equal 81 and 6x plus 6y less than or equal 36. This is equation 1, inequality 1, sorry, inequality 2. The first inequality is non-linear, the second is linear. Okay, good, very good. Similar, very, very similar. Very, very similar. Entonces es my rectangular, let me try to find my rectangular coordinate system paper. Okay, good. Okay. So this is circle again. Tell me, guys, where is located this circle? And what is the center and radius?
Center is 0, and the radius is what, 9?
Uh-huh. Where come from 9? Where come from 9? 7, 8, 9. 7, 8, 9. 7, 8, 9. This is my circle. Where come from 9? How do you know it's 9? Exactly. Square root 81. Okay. And solid or dotted?
Solid.
Uh-huh. I shade inside or outside?
Outside.
Outside. Why? Why outside? I need to understand why.
Wait, it's 81 is greater.
I don't care. I guess 81 is greater. Okay, suppose. Wow.
The equation is less than or equal to, so it's inside.
Absolutely. This is the idea. Okay, let me explain in a different way.
Sorry, I kept saying outside, but it's inside. I apologize.
No, it's okay. You are a student, no? You are learning. In the test, no. I have no forgiveness, but in the lecture, yes, you make a mistake. Maybe I make a mistake. The only difference between you and me is I passed this class, no? Do you see the board? Oh, no?
Yes, sir. We see the board.
Okay. So one mnemonic UI to remember si es inside or outside is when there's a closed figure, circle, ellipse, something like that, and it's less than to say it's inside. Less than and greater than, no, it's outside. Like a song. To say it's inside, I shade up. Let's go to the line. Well, the line is weird. 6x plus 6y less than or equal to 36. We can divide by 6, right? Yes or no? We can divide it by 6 or no?
Yes, we can. Do we make it greater than equal to an equation first?
Yeah. Either way. My recommendation is, first of all, when you realize it's possible to divide by 6, so you simplification a little bit, your inequality. And you isolate the y, like the inequality. Now, I convert to equation. Now ready? Wait. I make a mistake, right? I make a mistake, right? Do you think I make a mistake? This is 6 here, huh?
Is it on the wrong side?
Absolutely. You divide by 6. Look. And doing too fast.
X plus Y is equal to 6.
Yes, of course. If you divide by 6, what happens with the mouse? Yeah. You divide by 6 here. 6. So because 6 here. Okay, it's 6 here, it's 6 here. Now the y-intercept is 6. A lope is -1. That means it's 1 down and 1 to the right. And we're connecting this point by the line, by the way, passing through 6, no? The 6,0 is also x-intercept, and this is y-intercept. Okay. Again, 45 degrees, no? I suppose. Let me see. Yes. Solid or dotted? Hmm? Wow. It's solid, right? It's solid.
Solid.
Yeah.
Solid.
It's solid. Okay. And what parade shape? Below or above?
Below.
Below. Let me finish here. My solution is similar to the other problem. It's something like that. Include the H inside the solution or not? So for example, is H is included inside the solution, yes or no?
Yes, it is.
Yeah, and this one? Also, right?
Yes, sir. All the way around.
The reason is clear.
Everything inside the 9.
Exactly, because it's equal, no? In both. Include the H. This and this. Okay, let's go to Desmos to see the solution. Okay, this was 20, no? 20 is, look, circle and a line. A circle and a line. Very, very similar, but in this case, the circle, the radius 9, sin 0.0, and the y-intercept and x-intercept in this line is 0.6 and 6.0. 45 degrees, pero down, because the slope is negative. Any question? No?
No, sir.
Okay. Okay. Erase the board. Okay. Now 21 and 22 is a little bit more complicated because it's a typical linear programming problems. But don't worry, it's easy. 21 first. 21 is we have objective function. Objective function is 15x plus 13y. And I need to maximize this. I need to find the maximum value of this inside the solution or the region get solution for the constraints. So we have several constraints, and this constraint format a system of inequality. Okay, this is the constraint. Constraint is a system of several inequalities, maybe 1, 2, 3, 4, 5. And when you, the first thing you should do is plot the system and solve the system and find the solution of the constraint. And this give me a region. And this region is the like a feasible region. So it's when there's valid this objective function. So I need to investigate inside this region what is the maximum value of this. Okay, normally this situation happen not inside the regions, you know, in the edge, or maybe in the vertex, in the corner of this polygon. Let me try. Maybe it's confusing, too much blah blah blah. Let me try by hand. My rectangular coordinate system. Okay. Okay. Let me start. Entonces, the first inequality say x is in between 0 and 10. Bueno, this is 7, 8, 9, and 10. Solid, no? Solid line, 90 degrees. And solid 9 here, 90 degrees. Basically, it's that part. I don't want to highlight in order to doesn't confuse. But it's inside. Suppose that this is the 3. And between 0 and 10. This is x equal 10. 10, 1, 0. And this is x equal 0. This is 3. This is 3. But I want to erase this. This is the solution for the first. The solution for the second is y. And between 0 and 5. This is 5. Again, solid. And 0 is this, the x-axis. So the solution of the second inequality is this part. Do you follow me?
Your screen is still up on blocking the blackboard. Your computer screen. It's blocking it on mine. I can't see the blackboard at all.
Okay. Let me try again. Now?
Yeah, I can see it now.
Okay, good. I start at the beginning, right? I start at the beginning. The first inequality is this. It's the x value between 0 and 10. The y-axis is x equals 0. And the vertical line x equals 10 is this is the lower, and this is the upper, no? In this region. So basically, see, I try to highlight this using blue color, should be the upper. Yes or no?
Yes.
Regardless, I don't care.
I can see it.
I don't care. I don't care the y value. The y value is completely irrelevant in the first. And the second, no. And the second is from 0 to 5. 0 and y is exactly coincident with the x-axis, and 5 is a horizontal line, no? Like that. And see, you shape the inequality number 2 only should be that part. Okay? But let's do it why not the coincidence and between. Let me extend a little bit the axis here. It's a thing. So far, the solution for the inequality 1 and the inequality 2 should be this region. Yes or no? It's a rectangle. It's a set of the points such that x is in between 0 and 10 and y is in between 0 and 5. Okay, but no. This is not the final answer because I need to do the graph of the third inequality. Had you say something, mister? No? Okay. Let's do it exactly the same. In the third one, I solve for y. 2y greater than or equal minus 3x plus 6, no? Divided by 2. Divided by 2. Divided by 2. Y is greater than or equal minus 3 over 2x plus 3, no? Entonces you plot the y intersect is 3. Boom. And the slope is negative 3 over 2, so it's 3 down. 1, 2, 3, and 2 to the right. 1, 2 here. I do the line like that. This is a short line. Not necessarily. What part I shape? Below or above? Below or above? Above, below?
Above.
Above. And entonces above, in my opinion, is that part. And the green color, I try to shape the polygon que is formed by the solution of these three inequalities, 1, 2, 3. Ajá, y I discover que this polygon contain 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Es pentagon. Es pentagon. This polygon is pentagon because contain 5 sides. 5 sides. 5 sides. Let me read it. Okay. This point is the point 2,0. This point was 0,3. This point was 0,5. This point was 10,5. And this point was 10,0. And I substitution x and y of this corner inside the objective function and verification when it's maximum or when it's minimum. Let's do it quickly. Let's do it here. You evaluate z. By the way, I'll copy c again. 15x plus 13y. And you evaluate c and the point 0,0. Que es this point. No, 0,2. 0,0, no, sorry. 2,0. Here. Entonces I propose you travel clockwise. Like that. Entonces, 15 times 2 plus 13 times 0. Es obvio que es 30. 15 times 2 es 30. Evaluate C en 0,3. Que es the next point. 15 times 0 plus 13 times 3. Oh, it's 39. Okay, entonces now I can see that this point win, no, to the first point. Because remember, I need to maximize. I need to find the maximum value of this objective. Next, 0,5. 15 times 0 plus 13 times 5. It's 65. Okay, so far this is better. Let's do it 10 and 5. C and 10,5 is 15 times 10 plus 13 times 5. Put in the calculator, the answer is 250. This point. Now finally, the last point. C evaluate en 10,0. Es 15 times 10 plus 13 times 0. Es 150. Okay, entonces es obvio que the answer is this point, and you express the answer like that. That the maximum value of C is 215 at x equal 10 and y equal 5. Oh, like that, 10,5. At the point, 10,5. Okay, what's the point in which you get the maximum value? Any question? Linear programming. Linear programming, remember, you have, let me show you quick. Say again?
Say the answer again when you had the at. I lost you at the at.
Because.
The answer is.
Okay. The answer is C maximum value is 215. You understand very well this.
Yes,
and this value occur at the point
okay.
10 at the point 10,5.
Okay,
This point.
Understand.
I know. Okay, so basically, linear programming problem contains two pieces: objective function and constraints. Okay, you start always with the constraint. The constraint form a system. And the system, when you plug, not always, but frequently, you can get polygon. So you evaluate, because this is a line. I want to illustrate in this one now. Suppose that this line represents the objective function. Look. And you can translate this line in both directions. But what is the maximum value? Well, the maximum value I suppose is this. This is no maximum, and this C is equal to 10, to 15, sorry. This is 150, and so on, no? Okay, entonces, never inside the region, es the solution, you know, in the corner, es the maximum. Maximum or minimum, depending on the problem. Let me see in decimal to see more clear, more clear, more clear, more clear in decimal. Okay, you. Boom. 21, 21st. You see decimal now? Okay,
Yes,
and decimal I write, look. Okay, let's do it one by one. Boom, boom, boom. And boom. Okay. This is my first inequality. And the point, let me erase this. Okay, look. At the beginning, we have nothing. Rectangular coordinate, plain and blank. This is the solution for the first inequality. This is 3, and between 0 and 10. Okay, it's a vertical strip. The second is like that. So far, we have this rectangle. So you include the last constraint, boom. So we have a polygon. Okay, the polygon is formed using the 5 corner. This is the 5 corner, look. And this is the point associated with the 5 corner. Now, my objective function, I put in black color. Look, this line represents the objective function. I create one slider, it's easy. You put C equal 300, I put 300, it's the maximum value. And you can move the position for the objective function. Do you remember the number, right? Suppose exactly here, on this point. 215, no, approximately, no? 215, 215, no, you can change, you put 15 here. Yeah, you put it directly here. 215 is exactly on the point. You continue move 150, you remember 150, right? 150 is the value for the Z value in this corner, right? I don't remember very well what that is. A 65, I suppose, no? 65.
65, 39, 30.
35, 65, look at that, 65, approximately, no? 39, 39, and 30, no?
Yes, sir, 30.
Super, guy. More clear, nothing.
Okay, I get it.
Okay? Okay, let's do the last one, because it's a little bit more complicated. That's it. Sure. We come back to the whiteboard. Let me erase the whiteboard. Okay. This is the last one. 21, 22. We have again objective function that is C equal 6x plus 7y. And we have several constraints. X greater than or equal to 0, y greater than or equal to 0, 2x plus 3y less than or equal to 12, and 2x plus y less than or equal to 8. This is the constraints. This is the objective. Okay, so we start for the constraint. Let me try. This is my paper. Here. Okay. The first and the second constraint, 1, 2, represent the first quadrant. Yes or no?
Yes.
X0, together, no? X0, Y0 represent the X. The only region can satisfy both conditions simultaneously is any point in the first quadrant. It's continuous forever, no? But let's try the third inequality. Again, solve for y, 3y less than or equal minus 2x plus 12, no? Divided by 3, divided by 3, divided by 3, y less than or equal minus 2 over 3x plus 4. Entonces this point 4 is the y in the center. And 2 down and 3 to the right. 1, 2, 3. And we connecting this point with a straight line. But I don't care the second quadrant, the third quadrant. No. I care only this piece. Let me try. Something. Yeah, it's okay. It's passing through the point 6 because 6, 0. See, x is 6. 6 times 2 is 12, and y is 0. Perfect, matching. And you shade. In what direction you shade? Below or above? Below or above?
Below.
Below.
Right.
So far, we have this region, no? Consider the inequality 1, 2, and 3. Let's see what happens when you consider number 4 inequality. Well, this is similar. Let me try here. Is, well, easy. Y alone less than or equal minus 2x plus 8, no? So the y and z is 8. It's too far. This is 7. Not too far. This is 8. This is the y and z 8. And the slope is 2. Negative 2, negative 2. This is 2 down, 1, 2, and 1 to the right. Right. And we're connecting this line and this line. Using my hand. And this is the intersecting. In this case was 6 and the intersecting was 4. And this is no coincidence. Que this point is the point 3,2, no? And you shade in what direction? Below or above? Below again, no?
Below.
Below, inside the green part and inside. Entonces I suppose que my feasible region is the intersection, que in my opinion, guys, is this. Let me use in black color. This H, this H, this H, and this O, and this H. Basically, this is my feasible region. So let me use a red color. The point, the corner is this corner, 0,0. This corner, que es 0,4. This corner, que es 3,0. And this corner, que es 4,0. And the rest is just evaluate. In this corner, because it's a quadrilateral, no pentagon, a four side. Evaluate the objective function. Let me copy objective function again. The objective function is C equal 6x plus 7y. And you evaluate in 0, 0. Wow, es obvio que es 0, ¿no? Es 0 porque x0, y0 multiplied by a number 0 plus 0, 0 plus 0 is 0. Evaluate now, move clockwise. That was the first guy. The second guy is 0,4. Entonces 6 times 0 plus 7 times 4, 28. 28. And now what's the next corner? Is 3,2. Is 6 times 3 plus 7 times 2. It's 18, 14, 32. C, and the last one gets 4,0 is 6 times 4 plus 7 times 0 is 24. It's obvious that 32 is the maximum value, so C maximum is equal to 32 at the point 3,2. In other words, on the X is 3 and Y is 2. Any question? Do you understand very well linear programming?
Pretty good.
Yeah, please. Go ahead. Go ahead. Question.
I was saying it's pretty good. It's pretty clear.
Okay. Just in case, let's see in Desmos the solution. Always you are doing Desmos. So you are doing in the paper, and some people print out and scan. I don't know exactly, or you take a image of the Desmos. There are many ways. You using your imagination. And send me the image of the Desmos. Okay, let's move on to Desmos to see the problem 22. Okay, 22. Here, there. Okay, 22. Oof, look at that. I'm using the red color. Okay, let's do it step by step. Look. Let me delete everything. No delete, put on enable. X equals 0 and Y equals 0 is the first quadrant. Look. This is my third inequality, my fourth inequality. Now the corner is this corner. Okay, I put in black color. This is the value for the X and Y point in each corner. And the objective function, well, I copy. I put a one parameter. So I call Z or I call K, whatever you want. And you're using a slider. Look, at this point was 32, no? Look at that. And this point was, I don't remember, 28, no? 24. And this point was 28, no? 28, look. And this point, look. And 0,4 was 28, no? 28.3, 28. And 0,0 is obviously. Wow, amazing. This is a chain. If I have no time to apply this in the word problem, no? How you apply this in the real life, in the word application problem. But no, it's okay. At least you see the mathematical application. See, in one moment you need to apply, the linear programmer for the optimization. Okay, so remember, guys, stay with me using another computer. Let me stop sharing. I want to see your face now. Do you see my face or no? Okay. So using another computer, I want to send the test. You let me know when you receive. You say, I got it, yeah, you can leave. Okay? Boom, I sent. Go.
All right, Professor, I got it. That's number 2 due October 27. Don't forget.